Now we'll look at two examples of determining limits at infinity where the functions involve square roots. We know from the previous examples when we had a rational function, we always divided every term by the highest power of x from the denominator. But in this case, since our function involves a square root, we have to be extremely careful about the signs. So instead of dividing by the highest power of x from the denominator, we're going to factor instead. But before we do this, the reason we have to be so careful about determining these limits is because if we have the square root of x squared, this isn't equal to just x. This has to be a positive value. Therefore, it's equal to the absolute value of x. Which means the absolute value of x, if we want to write this in terms of x, is equal to x if x is greater than or equal to 0, but it would be negative x if x is less than 0. Meaning if x is negative, we can write the absolute value of x as the opposite of x. And we'll have to do this when we factor to determine these limits. So since our denominator is 4x plus 3, we're going to factor out x from both the numerator and denominator. So let's start with the denominator. We'll have the limit as x approaches infinity. If we factor out x from the denominator, we would have x times the quantity 4 plus 3 divided by x. Notice how x times 3 divided by x is still 3. Now we want to factor out x from the square root. But we know if we factor out an x from a square root, it would actually be the absolute value of x, which in this case, since x is approaching positive infinity, or x is greater than or equal to 0, we can just factor out x. But if we factor out x, remember underneath the square root, it would actually be x squared. So if we factor out x squared underneath the square root from 5, we would have 5 divided by x squared. If we factor out x squared from 4x squared underneath the square root, we would just have plus 4. Now that we have this in factored form, x over x simplifies to 1. And now we'll see what happens to each term as x approaches infinity. Well, 5 divided by x squared would approach 0 as x approaches infinity. Notice how this 4 and this 4 are not affected by x, and 3 divided by x would approach 0. So we're left with a numerator of square root 4 and a denominator of 4. Well, the square root of 4 is equal to 2. 2/4 is equal to 1/2. So this first limit is equal to positive 1/2. Now let's consider the second limit. And notice the only difference here is that x is approaching negative infinity. So we'll start again by factoring out x from the denominator. So we'd have x times the quantity 4 plus 3 divided by x. Now we want to factor out x from the square root, but again we know that value has to be positive, and now x is approaching negative infinity. So the absolute value of x would be equal to negative x this time because x is less than 0. So if we want to factor out x, we'd have to factor out negative x, again because x is approaching negative infinity. Therefore this is now a positive value. And then we're still left with, underneath the square root, this would still be x squared. So we'd have 5 divided by x squared plus 4. Now that it's in factored form, notice how negative x divided by x simplifies to negative 1. 5 divided by x squared still approaches 0. So does 3 divided by x. And this 4 and this 4 are not affected by x. So the only difference here is that we would have negative square root 4 divided by 4, which would simplify to negative 1/2. So as you can see, we have to be extremely careful when determining the sign of our limit if the function involves a square root. Now let's go ahead and graph our function to verify these two limits. Notice as x approaches positive infinity, it does appear the function value is approaching positive 1/2. And as x approaches negative infinity, it does appear the function value is approaching negative 1/2. This also verifies that our function has two horizontal asymptotes. One is y equals positive 1/2, and another that's y equals negative 1/2. So we have a horizontal asymptote of y equals 1/2 to the right, and y equals negative 1/2 to the left. Okay, I hope this explanation was helpful.